Science predicts that intelligent life could not have structured itself during the contraction phase of the universe due to the problem of entropy. However, since we can only record the inflationary phase of the universe in a time-delayed manner, it follows that our physical body must have been structured in some mysterious place outside of here, where potential energy predominated over kinetic energy. A place in continuous expansion, which would support the increase in entropy. The fact that we can only record the inflation of the universe in a time-delayed manner becomes an obstacle to our direct interaction with its matter. Galaxies, like subatomic particles, are always seen outside their real position and their own time. The time lag also tells us that unlike our physical body, our intelligence would have been structured within space-time, reducing disorder and reorganizing the pieces on the board at the information level. This inverse movement would have made us dependent on our memory. For it, all that exists is what can be remembered. Apparently, even knowing that this is something unquestionable, scientists have not given due importance to the fact that the expansion of the universe, suggested by tracking cosmic radiation, shows us a picture that would belong to the universe's past. For this very reason, this radiation is called background radiation. Bearing in mind that when we look at the celestial vault at night, we would be seeing an image of our distant past, there is no guarantee that the expansion is still ongoing in the present of the universe. It may be, it may not be. From our point of view, the past seems to have taken the place of the present, preventing us from seeing the galaxies in real time. The importance of the detail is that this time lag would change our assessment of the effects of entropy, since it would be expected that it should increase only in the inflationary phase. In other words, the increase in entropy would also be assessed by the cosmic background radiation outside its own time. After the reversal in the direction of the arrow of time, which would have accompanied the Big Bang, the background radiation tells us that disorder would be increasing in real time. However, at this point, the arrow is already pointing towards our past, a dimension of time that no longer exists. When it is said that the real arrow of time would always point towards the future, following the increase in entropy, this would be perfectly logical and acceptable. However, if this reversal of the arrow of time had occurred only at the level of light and the information it carries, the observer could have been projected into the past, placing himself dependent on his memory. For example, the time that separates us from the Big Bang, estimated at 13.7 billion years, is perceived thanks to the late projection of information onto the celestial vault. This time is usually assessed indirectly through the cosmic background radiation. Since our brain will always have the final say, interpreting the information that reaches us from deep space, this indirect method of assessment, remote tracking, would be nothing more than an appendix to our memory. In fact, the observer's physical body would never have left the present, but his brain could only look at it with a delay. In this case, the real movement of time should be toward the present, but it appears to be toward the future. This is understandable, because when one evaluates the present from a position assumed in the past, the future and the present become the same thing. The first has not yet happened, and the second is always escaping us. The impression that remains is that the only path that would take us back to the present of the universe would point from the past to the future. In this case, we could say that the passage of time would be taking us back home. To reach the present of the universe, we would necessarily have to travel through the past, suggesting that we would be living off our memories, enclosed in a kind of temporal exile. Until we return to the present, the movement of time would always have to be toward our future. By tortuous paths, we arrive at the same conclusion as science. As would happen with our electron, the observer's consciousness, supported by his memory, seems to place him in more than one place in space at the same time.